Think it, print it. It's that easy, right? Well, maybe not. In this video, we'll take a look at some common misconceptions and the reality of FFF, fused filament fabrication type of 3D printing, including surface finish, print quality, and object strength right off the printer, and some post-processing techniques that are commonly applied to fill the gap between fresh off the printer and amazing. The 3D printing industry is growing faster than ever expected. Due to this rapid growth and the resulting hype surrounding 3D printing, one common misconception is the as-printed look and feel of an object. Often a user expects a part to look completely finished when it is done printing, but in reality, the post-processing involved to get the part looking this way may have taken several days or even longer. Let's take a closer look. This rim was 3D printed using a commonly used plastic called PLA, polylactic acid. The part was relatively inexpensive to print, costing only about $250 in material. The model modifiers were set prior to printing to ensure a strong part with enough infill and wall thickness to enable post-processing. The part also needed a considerable amount of support structures due to the steep overhangs in the model. When the print was complete, the breakaway support structures needed to be removed. Post-processing techniques were then applied. The end result shows the dramatic difference between raw, fresh off the printer, and the finished piece. Let's take a look at a few more examples. In this example, Frankenstein was printed on a gigantic scale, measuring in at 695 millimeters tall. Again, some commonly used post-processing techniques were applied in order to create the museum-quality aesthetics. Deburring removes all the sharp edges of plastic that may be remnant of the support structures. Priming with a high-build automotive primer. Sanding, ranging from coarse to fine grit. And airbrushing artistic details. This example shows the incredible amount of detail involved in creating a photorealistic model of a sailing yacht. Other techniques for finishing 3D printed parts include acetone vapor treatment for ABS, water and ultrasonic waves combined to remove support structures, a variety of other chemical and sealant treatments to smooth outside surface finish. It is important to understand that there are many post-processing techniques that can be applied to your 3D printed part in order to make it showroom quality. But you have to have the tools and the know-how to accomplish this, which quite honestly, not many of us have. Here at 3DP Unlimited, we trust the artists at Psychology in Evansville, Wisconsin, and the 3D print experts at C-Ideas in Crystal Lake, Illinois, to help bring our prints to life. So now you're probably thinking, what can I do if my project requires high print quality, but I don't have the budget to hire professionals for post-processing? There are several things in your control that will help get the best surface finish possible. Determine the best nozzle diameter and layer resolution for your project. Keep in mind the relationship between layer resolution and print time. A large diameter nozzle with a thick layer resolution will print much faster than a small diameter nozzle with a fine layer resolution. For example, an object that takes 100 hours to print with a 0.4 millimeter nozzle can print twice as fast if printed with a 0.6 millimeter nozzle, and you can cut even more print time by increasing the nozzle diameter to 1.2 millimeters. What's the trade-off? The surface finish may be more coarse when using a large diameter nozzle. However, the thick bead of plastic that is laid down layer by layer also creates a very strong bond, resulting in a heavy-duty part. Once the layer resolution is determined, the speed settings for the printer have a direct effect on the quality and surface finish of the printed part. A slower first layer can help the object adhere to the print bed. A slower speed for the outside perimeter is important for high quality surface finish. If the part you are printing requires supports, the choice made regarding support material has a direct impact on the surface finish of the printed part. Breakaway support structures tend to print relatively quickly because they are not printed solid but can leave scarring on the object. Parameters are set in the software to aid in the removal of the supports. Washaway support structures are printed nearly solid and can be removed using water or certain chemicals. PVA is soluble in water. HIPS is soluble in limonene. Washaway support structures provide a high-quality surface finish for the printed part. However, the support material requires a high fill density, which means longer print times. Surface finish and overall print quality are often tested in the obvious way, feeling the part once it is printed. But when a more scientific approach is needed, the use of an optical comparator can provide a closer look. Determining the end use of any object prior to printing will allow the user to select the best print parameters to achieve the desired results. High print quality can be achieved using the FFF 3D printing process, but if the project requires showroom finishing, don't hesitate to contact a post-processing professional to help fill the gap between fresh off the printer and amazing.